Right, this is Unit 5, Lesson 5, Part 1. So these are 3 pages of notes. We're going to split them between 2 different days. So there's a step-by-step process. We're going to be solving polynomial equations by factoring. And we've solved equations by factoring before. They were just all quadratics. So we're kind of expanding, using all the different types of factoring that we've used, and we can solve a lot of different polynomials by factoring. So we are going to start by doing number 2 together. We're going to do 2 and 4 on this page. So I'm going to walk you guys through these 3 steps while we look at number 2. So step number 1, move all terms to one side and make sure the equation is set equal to 0. So if we start with that with number 2, we're going to subtract the 3x squared from the right over to the left. So when I subtract 3x squared, this will still be a 4x cubed. And then since this is an x squared, I'll combine like terms. So when I subtract a 3x squared, I end up with a negative 10x squared. And that means nothing's on the right-hand side. So I've got it set equal to 0. Step 2, factor the polynomial completely. So we've been doing a lot of factoring practice recently. Remember, your very first piece of advice that I gave you was to check for a GCF every time. Doesn't matter how many terms, doesn't matter what kind of problem, you're always checking for a GCF. So these two are both even, so we do have a GCF of 2. And then 3 copies, 2 copies means I have 2 copies of x in common that I can take out. So I'm going to factor out that 2x squared. So when I divide out a 2x squared here, I'm left with a 2x. And when I take out a 2x squared here, I'm left with a negative 5, but I took out all my x's. So negative 5. After you get a GCF, you want to look in the parentheses and see if there's anything else you can do. But since this is linear, like it's just an x, it won't factor any farther if I already took the GCF out. So then I move on to step 3, set each factor equal to 0 and solve. So that's what I'm going to do. We've done this plenty of times before. So you set each factor equal to 0. So this one, I take 2x squared and set that equal to 0. So I divide both sides by 2. So divide the left by 2. When I divide 0 by 2, it's still just 0. And then since it's an x squared, I can solve by taking the square root. Normally I do a plus or minus. This is the one and only time when I don't, because it's 0. Like there's no positive 0 versus negative 0. So I get x equals 0. As one of my answers. This one I set equal to 0. First thing I'm going to do is add 5 to both sides, and then second thing I can do is divide both sides by 2. So that 5 gets divided by 2. I always just leave it because like it saves you a step to just leave it, but if you want to put it in decimal form, you absolutely can. So just like we've been doing when we solve equations like this, we put our answer into a solution set. So I like to do it in numerical order. I put the 0 first and then the 5 halves after that. So this is our solution set for number 2. What that means is if I were to plug any of these, either one of these into this equation up here, it would make the 2 sides equal to each other. It would be true. So quick little just notes right here. If you're solving a quadratic equation at the end, you can solve by any of these methods. And as they pop up, we'll talk about what the appropriate method would be. And then if you have any irrational or complex solutions, you want to simplify them as much as possible. That hasn't popped up yet, but just a little side note. So we'll come back to that in future problems. Next one we're going to do is number 4. So step number 1, make sure everything is on one side. We've got equals 0, which we already do. So we skip right to step 2. Factor completely. So always start by looking for a GCF. Maybe you have one, maybe you don't. Here we do. 80 is also a multiple of 5. So I can take out a 5. And these both have, this has 5 copies, this has 1 copy of x. So we can take that out too. So parentheses, set that equal to 0. If I divide out a 5x, I have 4 copies of x left here. Minus, and you might need to do this on a calculator, but 80 divided by 5 is 16. And then I took out the x. So this can be factored down farther because this is technically the difference of squares. It's 2 terms, it's subtraction. This is a perfect square. And remember, if this is an even exponent, then it's technically a perfect square. So I'm going to keep on factoring. So I factor, remember I have 2 binomials that are the exact same. So x to the 4th would be x squared times x squared. And then the minus 16 would be a plus 4 and a minus 4. That's our difference of squares pattern. So then keep looking. This is a quadratic, so it might factor more. It doesn't because I don't have a sum of squares pattern. You'll never be able to factor those. This one is actually another difference of squares. Difference, this is a perfect square, this is a perfect square. So that second one will factor down a little bit farther. So this just stays the same. This one I can factor down to 2 more binomials. So for the x squared, I have x times x, and then the minus 4, I have plus 2 and a minus 2. So now these are linear, they don't factor down anymore. This is a sum of squares, which will never factor down. So now I'm completely factored, and I move on to my last step where I set each factor equal to 0 and solve. So I have lots of things to solve for. I'm going to set each one of these pieces equal to 0. Lots of things to do. So set this one equal to 0. If I take 5x and set that equal to 0, all I have to do is divide by 5, and 0 divided by 5 is still 0. So there's one answer. This one, if I set that equal to 0, x, zoom in on this a little bit. Here we go. So this, I would subtract 4 from both sides because we've got quadratic equations. We have multiple options. Square roots is the one, oops, I'm pointing to something that's not on the screen, sorry. Square roots is what you're going to want to go with here because there is no b term. You just have a squared term and a number, so we can solve by taking square roots. So you're going to want to subtract the 4 from both sides. So we have x squared equals negative 4, and then you can solve by taking a square root. So square root both sides. So we get x equals, it does start with a plus or minus, and then this is a negative under the square root. So here is your reminder to simplify irrational and complex solutions. This one's going to be an imaginary number. So square root of 4 is 2, and then with the negative, it's going to be 2i. So 2 different answers there because it's a quadratic. This one, if I set that equal to 0, I'll take x plus 2, set that equal to 0. All I have to do here is subtract 2 from both sides. So I get negative 2, just a normal real number. And if I set this equal to 0, I add 2 to both sides, and I get 2. All right, so all of our answers here, we can just write them in like plus or minus form. So we have 0, then we have plus or minus 2i, and then negative 2 and positive 2. So we can write that as plus or minus 2. So any of these are technically 5 different answers. If I plug them into my original equation, it would make the equation true. It would come out to equal 0. All right, so a couple problems on the fronts. We're going to move to the next page. Zoom back out a little bit. All right, so we're going to look at number 6 next. So following that same 3-step process, first step is to move all terms to one side. So I need to subtract that 4x squared. So I have 8x to the 5th. When I subtract 4x squared, this is just an x squared. And that's equal to 0 because I had 5 minus 4. First step is to always look for a GCF, and I do have one here. They both have 2 copies of x. And then I write my leftovers. So without an x squared, this is an 8x cubed. And without an x squared, there is still something there. When you divide x squared by x squared, you're left with 1. Don't forget about that. So this pattern is the sum of cubes. When it's 2 terms, it's either the difference of squares, the difference of cubes, or the sum of cubes, or it doesn't factor. But this is a sum, obviously, and these are both perfect cubes. Perfect cube, and this exponent is a multiple of 3. So I can set up that pattern. So let me write that up above here. The pattern for the sum of cubes is this. So you might want to keep these out as you do problems just to remind yourself of the pattern. So I keep my x squared out front, and then for my sum of cubes, I have a binomial and a trinomial. I set that equal to 0. So my a plus b, remember, just means I'm uncubing these. So if I uncube the 8, I get 2. And then uncube, I just have an x. Keep the same sign as the original one had. And if you uncube a 1, it's still 1, because 1 times 1 times 1 is still just 1. Then my trinomial here. A squared means I square this guy. So if I square 2x, it's 2x times 2x, which would be a 4x squared. Switch the sign. A times b means I multiply these two things together. So just 2x times 1. And then this is always a plus back here. And I finish off with b squared, which means I square this guy. So if I square 1, it's still just 1. So those are all of my pieces. This is a quadratic that doesn't factor down any farther. So when we're solving in the next step, you're going to want to use the quadratic formula. So we have all of our pieces that we can set equal to 0. When I set x squared equal to 0, I take a square root. Remember, just like the front page, I just get 0. There's no plus or minus when it's 0. I take 2x plus 1 and set that equal to 0. 2 steps. First, I subtract 1 from both sides. And then second, I divide both sides by 2. So I get a negative 1/2. Now this is a quadratic that doesn't factor. So if you're doing sum or difference of cubes, you're going to solve this piece by doing the quadratic formula. So let's set that up. So we have x equals, remember the quadratic formula, we start with negative b, so that would be a positive 2, plus or minus the square root of b squared. When I square this, I get 4, minus 4ac, so 4ac would be 4 times 1, which is 16, and then all of that over 2a. 2a is 2 times 4, which is 8. So I'm doing some of the quadratic formula in my head, but we've done quite a bit of it already. Equals 2 plus or minus, this ends up being the square root of a negative 12, which means imaginary answers are coming, over 8. So the negative 12, I can split that into negative 4 and positive 3. The negative 4 will come out, the 3 will stay under a square root. So I have 2 plus or minus, square root of negative 4 would be a 2i, just like the previous page, and the 3 gets left behind. All of that over 8. So I can reduce down if all 3 of these share a factor. So all 3 of these are even, so I can reduce them all down. All right, so I am going to squeeze my answers over here. So I have x equals, I've got the 0, I have the negative 1/2, and then I'm going to reduce this down by 2. So 2 reduces down to 1, plus or minus, this reduces down to 1. So I'm just going to write I root 3, and this reduces down to 4. So I reduced all those even numbers down. So there are all of my answers for number 6. We're not doing number 5, so we can bleed over into that problem a little bit. All right, we're going to do one more in this set, and that is going to be number 8. So number 8, same first step. We get everything on one side, set it equal to 0. So I'm going to subtract 54 from both sides. So I have 16x cubed minus 54 is equal to 0. Always look for a GCF first. It's not much, but they are both even, so I can take out a 2. So this is 8x cubed minus 27 is equal to 0. So now without the 2, these are perfect cubes. These aren't, but these are. And so this is now the difference of cubes. So I can write that pattern up here. So the difference of cubes is a minus b, a squared plus ab plus b squared. So it's going to be really similar to number 6. I'll give you a little bit more practice with this stuff. So factor down, the 2 is still out front. And then I have a binomial and a trinomial. So for a minus b, I just uncube these pieces. So if I uncube the 8, I get 2, and then an x, minus uncube the 27, takes me back to 3. So this is a and this is b. I can use that in this pattern. When I square the a, it means I'm squaring 2x. So 2x times 2x is 4x squared. Then it's plus a times b. So a times b would be 2x times 3, and that's 6x. Plus b squared would be 3 squared, and that's 9. So just like the one up above, set the pieces equal to 0. For this part, since it doesn't factor, and since it has an x term, you're going to do the quadratic formula. All right, so set each piece equal to 0. 2 does not equal 0, obviously, because it's a number. So when we set that equal to 0, it doesn't give me any solutions. I can set this one equal to 0. First step I'm going to make is adding 3 to both sides. And then the second step would be dividing both sides by 2. So I get 3 halves, or 1.5, or 1.5, whatever you prefer. And then with this part, I'm going to do the quadratic formula. So anytime you have the sum or difference of squares, this part is always going to be solved with the quadratic formula. So I have x equals negative b would be a negative 6, plus or minus the square root of b squared. When I square the 6, I get 36, minus 4ac, so 4 times 9. So 4 times 4 is 16, times 9 would be 144. All of that over 2a, so 2 times 4 is 8. Again, doing some of that in my head. Equals negative 6 plus or minus under that square root. So 36 minus 144 is a negative 108. And then that's over 8. So keep simplifying that square root. Negative 108, it's a multiple of 36. So I can pull out a negative 36, and then I'll have a 3 left behind. So 36 and 3 gives us 108. So the square root of negative 36 is a 6i, and then the 3 is left behind. That's all over 8. So just like I did up here, 6, 6, 8, those are all even, so I can reduce those down. So let me write my answers. And we're not doing 7, so we can squeeze them in over here. So our answers are the 3 halves that we had from the first part, and then here I can reduce these down by 2. So negative 3 plus or minus 3i root 3 over 4. So this doesn't reduce, it's just like the constants out front that we can divide them all down by 2 if they all share a common factor. If only 2 of them do, you can't do that. So that is our final answer for number 8. And that's where we're going to stop part 1.